Warm welcome you all to channel Meet MIT, that is Math is Tricky.
The question is, in how many ways can the letters of the word Monday can be arranged? How many of these arrangements do not begin with M? How many begin with? How many may begin with M and do not end with Y? This is the problem. Let's see the solution. Solution is here. So the word is here Monday. 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 So 1, 2, 3, 4, 5, 6. N equals 6. Number of letters 6 here. And so they can be arranged. Total arrangements equals simply 6 factorial. It is 720. Equals here 1 into 2 into 3 to 4 into 5 into 6. So it is here 6 and 24, 120 into 4, 6 is 720. Now for second part, the condition is here. This first one, how many of these? So how many of these arrangements do not begin with M? For second part, so it means here do not begin with M. So let's see here, do not begin with M. So 1, 2, 3, 4, 5, 6. We can't put here M. We can't put this M here. So it means here, except one we can put one of this remaining. So 1, 2, 3, 4, 5. 5 choices are here for first. Now remaining this can be filled with. Now if we can put here, remaining 5 can take this first place. Now others 5 will be arranged, can be filled with the remaining 5. Suppose if we are taking here O, so again there are just 1, 2, 3, 4, 5. So 5, 4, 3, 2, 1, or simply we can write here 5 into 5 factorial, and it is here 5 into 5 factorial is here 20 into 6 is 120. So answer will be 600. This is the second first one. Hope you are understanding this. Now for the third part, how many may begin with M and do not end with Y? So for third part here, 1, 2, 3, 4, 5, 6. Let's write here 6 places. So first see here, begin with M means we have to put here M. So only one choice, not begin with Y. So already we have taken M. Again we are not allowed to take this Y. Okay, so remaining 1, 2, 3, 4 we can put here. So 4 choices for here. So 4 choices, maybe here we can put here M. M is already there. So O, maybe N, maybe D, maybe A. 4 choices. Now for this remaining 4 we can write here 4, 3, 2, 1. That means 1 into 4 factorial into 4, and it gives here, so 4 is a 12, 12 into 6, 4 is a 24, 24 into 4, it is here 96. Okay, these are our answers. Hope you understood this. So it's very simple. According to questions, we have to arrange the letters of Monday. Okay, maybe Sunday also, Tuesday also, Wednesday. So in a simple way we can solve the problem. So first one is, in how many ways these letters can be arranged. The letters of Monday can be arranged. It's very simple because it contains 6 letters, 1, 2, 3, 4, 5, 6, and all the letters are different. So direct we can use formula 6 factorial. Simply 6 factorial means 1, 2, 3, 4, 5, 6. Multiply them and it is 720. Second part is here, how many of these arrangements do not begin with M? That means we can't write here M in first place. we are not allowed to write m in first place. That means this first place should be filled with O, N, D, A or Y. Okay, so there are 5 choices. So now remaining 5 places can be filled with 5 elements in 5 factorial ways. So it is here 600. So last one is here similarly. So we have just see here it should be start with m, so only one choice, and do not end with y means we can't put here y can't be kept here. So only 4 choices, m is already here, so 4 choices, remaining 4 can be filled with 4 elements in 4 factorial, so it is here 96. Hope you understand it here. Thank you so much. That the number of ways in which the letters of the word college can be arranged so that 2 is always come together is 360. Okay, first one, this is the solution. Then first let's solve first question and then we move to second. Solution is here for a, the word is here college, COLLEGE. So number of letters n is how much here? 1 2 3 4 5 6 7. So we have to arrange so that 2 is always come together. So it means here we have to write here arrange so that COLL and both E comes together, and G. See here 1 2 3 4 5 6 7, but 2 E's are coming together. It means here we have to count this as 1 1 2 3 4 5 6. So that means number of ways required will be simply here, let's see here, it is 6 letters as 2 each are together, so it will be 6 factorial. But see this 2, there are 2 L's, so it means here you have to divide by 2 factorial, so it is here 720 by 6 factorial is 720 and by 2 factorial means 2, answer is 360. This is what we have to prove. Okay, hope you are getting this. If we have to put 2 elements together or 2 letters together, that should be considered as 1. Okay, now so that here we have 7 letters but 2 E's are always coming together, so this 2 will be considered as 1. So now we have 1 2 3 4 5 6 letters, and that can be 6 letters can be arranged in 6 factorial ways. But here these we have 2 L's, so for that we write here 2 factorial, so total number of ways will be required will be 360. That is what we have to prove. So okay, let's move to second question, question number B. So for B, let's see how we are solving this. Arrange, here see the word is here arrange, ARRANGE, the word is arrange. So n number of letters will be here, number of letters here n equals simply 1 2 3 4 5 6 7, again 7. Now we have to arrange so that no 2 R's come together. Okay, so remember, if you have to find the number of ways in which 2 R's or 2 whatever a, maybe 2 letters are not coming together, so the process is always find first total number of ways. That means total number of ways is actually the number of ways in which 2 elements are coming together plus not coming together. So total number of ways will be total number of ways is here simply 7 factorial. See here 7 factorial, but this we have 2R and 2E. 2a, so it will be here 2 factorial and 2 factorial, so that we can write here 7 into 6 into 4 into 3 into 2 into 1 by 2 into 2, so 4 cancel, so it will be here simply 36 into 7 here 36 into 7, so it will be 2 and 21 and 2 140, sorry it is 5 is missing here, so okay, for this it will be simply 7 into 6 into 5 into 4 into 3 into 2 into 1 7 factorial by 1 into 2 into 1 into 2, it means here 4 and 4 we can cancel, so it will be 6 into 5 30 into 180, it is here 12 60. Okay, now let's find the number of ways in which two R's are together. If two R's come together, then which will be simply we have to write here two R's together means let's consider this as 1, so 1 2 3 4 5 and it is 6, so 6 factorial by we have 2a, so it is here 2 factorial, 6 factorial is 720 by 2, it is here 360, so required wage will be required wage, that means the wage, the total number of wage in which not two R's will be together will be 1260 minus 360 and it gives here 900. That is what we have to do. Hope you understood this. If you have any confusion, please share with me so that I can help you. So this is let me explain what I did here. Actually, I have found total number of weights, and then to find the number of weights in which two elements are not coming together, it's simply total number of weights minus the weights in which they are together. Okay, this is how we can solve the similar problems. Hope you understood this. If you have any confusion, don't forget to share with me. And if you have not subscribed my channel, please subscribe. The question is, in how many ways can the letters of word computer be arranged so that all the vowels are together? First question. Second is, the vowels may occupy only odd positions. And the third one is, the relative positions of vowel and consonants are not changed. Okay, so this, let's see here, first one for first. The word is here computer, COMPUTER. So N is 1 2 3 4 5 6 7 8. N is here 8, total number of letters. So vowels are together means we have to write like this, C M P T R, and then all the vowels, that means O U E, will be together. O U E will be together. It means here we'll have 1 2 3 4 5. This will be considered as 1, so will be only 6. So 6 letters, and the required base will be here. Required base will be 6 factorial, because these 6 letters can be arranged in 6 factorial ways, and these 3 vowels may change their position in 3 factorial ways, so we have to multiply by 3. So hope you understood this. We have 6 letters because 3 vowels are together. Okay, so they can be arranged in 6 factorial ways. Now these 3 vowels, remember, these 3 vowels, they may change their position among themselves in 3 factorial ways. So total ways will be 6 factorial into 3 factorial. So it will be 6 factorial is 720, and it is here 6. So it will be 4, 3, 2, 0. Just multiply this. So this is our required answer. For B, let's see. For B, we have solved this. Now move to B. The vowels may occupy only odd positions. It means here, see how many letters we have. 8 letters means 1, 2, 3, 4, 5, 6, 7, 8. It means here first, second, third, fourth, fifth, sixth, seventh, eighth. So we have to put the vowels only at odd positions. Look here, odd position means we can put here one choices, 2, 3 and 4. That means three vowels we have. Three vowels, they can be arranged in 4. For first vowel 4 choice, for second vowel it is 3 choice is there, for third one there will be 2 choice. Okay, so now remaining, see here how many places we have. 1, 2, 3, 4. So 1, 2, 3, 4. And 1 will be again remaining from this. So there are now 5 places remaining, and 5 places can be filled with the 5 consonants in 5 factorial. So it is simply here 12 into, it is 120 into 2. So it is here 144 into 2, 208 and 0. So simply just multiply. It is here 144 0 into 2. Okay, so simply we'll be getting here. So 2880, 2880 ways will be there. So understood? Hope you understood. So for three vowels, there are 4 choices, so they can be filled in 4 into 3 into 2 ways, or we can write here simply 4p3, and the remaining 5 places can be filled with 5 consonants in 5 factorial ways. So we'll be getting the answer as 2880. Now for the third part, so let me explain here how we are getting the answer. For part C, this is for C, the relative positions of vowels and consonants are not changed. It means here, so their positions are as it is. It means here, so we have three vowels and 5 consonants. So these 3 vowels can be arranged in 3 factorial, 5 consonants in 5 factorial ways. So total ways will be simply 3 factorial into 5 factorial. So 3 factorial means 6, 5 factorial is 120, and the answer will be 720. Okay, hope you understood this. And if you have any confusion, if you have any queries, please share with me so that I can help you. And once again, we warm welcome you all to channel Meet MIT, that is Math is Tricky. It's me, your Meet Ramsa, and I'm solving some problems for you. Now let's see another question. Question number 4. The question is like this. Find the number of arrangements of the letters of the word laptop so that the vowels may never be separated. Second, all the consonants may not be together. Third one is they always begin with L and end with T. The last one is they do not begin with L but always end with T. Okay, let's solve them one by one. For first, let's see here the word is here solution. Solution, the word is laptop, LAPTOP. So the word is here laptop, and if you see here 1, 2, 3, 4, 5, 6, n equals 6. Now for A, what you have to do for first, the vowels may never be separated. The vowels may never be separated means all the vowels are together. So write like this. So L, P, T, again P, and then A, O. They they are not separated, means they are coming together. So let's consider them as one. So there will be 1, 2, 3, 4, 5. 5 letters, and so required weight will be 5 letters. So 5 factorial. They can be arranged in 5 factorial ways, but there are 2 p's. See here, so we have to divide by 2. Okay. Also, these 2 vowels, they may change their position. A and O, 2 vowels may change their position in 2 factorial ways. So we have to multiply by 2. These 2 cancel. So we have here 5 factorial means 120 ways. This is our answer. Are you getting or not? So let me explain once more. We have here how many? 6 letters. So why we are considering these 2 as one? Because they are always coming together. They are not being separated. Means they will come together. So we have to consider them as one. So now we have 1, 2, 3, 4, 5 letters, and they can be arranged in 5 letters can be arranged in 5 factorial ways. But I'm dividing here by 2 factorial because these 2p, we have 2 p's, so for them we have to divide by 2 factorial. Again, I'm multiplying by 2. The reason behind this is because the 2 vowels which are coming together, they can change their position. Okay, they may change their position in 2 factorial ways. So total number of ways will be 5 factorial, that is 120. Let's move to second question. All the consonants may not be together. May not be together means, as we discussed in previous question, if we have to find not coming together, so we have to first find total number of ways, and then if we subtract the total number of ways in which they come together will be the required answer. So this is what I'm going to follow. This is how I'm going to solve it. So let's say total ways will be how much? Total ways first. Let's find the total ways. So we have 6 letters, so it will be here 6 factorial by 2 factorial, because here we have 2p. So 2 factorial, 6 factorial is 720 by 2 factorial, it is 360. Okay, so now ways in which consonants are together, consonants are together. So it will be how much? It will be simply here consonants are together means L, we can write here L, P, T, P as one, and then only A and O will be there. These all the consonants are together means this will be considered as 1, 2, 3. So it will be a 3 factorial, and then they can change their position in 1, 2, 3, 4, 4 factorial ways by 2, because 2p we have, so it will be here 2. So it is here simply 6 into 4 into 3, 2 factorial, 2 factorial cancel, so it is here 12 into 6, 72. And if we subtract 360 minus 72, will give here 8, and 15 minus 7, 8, 280. This is required ways. So it gives here required ways. So in which consonants will not come together. The total number of ways will be 360 minus 72 is 288. So now let's see the third one. Question number C. For C, they always begin with L and end with T. So let's write here 1, 2, 3, 4, 5, 6. We have 6 letters. So it begins with L means there is only one choice for first place. Now for last, it must begin with, it must end with T. So there will be again only one choice for. Now see here how many places are vacant. 1, 2, 3, 4. So now again we have already kept this L and T. So 1, 2, 3, 4. 4 letters, 4 places. So it can be done in 4 into 3 into 2 into 1. That means 4 factorial. But we can see a 2p, so by 2 factorial, so which required will be 4 factorial by 2 factorial, that is here 4 into 3 cancel, so it is here simply 12. Hope you are getting this. Hope you understood this. Okay, now we'll move for the last one. They don't begin with L but always end with T. So again let's write here. Let's write 1 2 3 4 5 6 6 letters. They must begin with they do not begin with L but end with T. So T must be at last. So only one choice for last place. And they do not begin with L means we are not allowed to write here L. We can write here L. We can write T also already used. So these are not allowed. So we have only L and T we can write means. So we can here we are not allowed to write L and T, L and T. So we have 1, 2, 3, 4. 4 choices for this first place. 4 choices we have. So that means we can write only A, P, O and P. Again here 4 choices. Now 4 choices, but remaining 4 places 1, 2, 3, 4 they can be filled in 4 factorial, but we have as 2p, so it will be divided by 2 factorial. So which required will be here required, which will be in this case will be simply 4 into 4 factorial by 2 factorial, and 4 factorial by 2 factorial already we have calculated, so 4 into 12 it is here 48. This is our answer. Hope you understood this. uh, it's not so difficult. You just need to practice a number of times and solve many more problems so that your concept will be clear, and by practice you, you can increase your confidence level. Hope you are getting, and if you have any confusion please share with me. Thank you so much. God bless you. How many different words can be formed with all the letters of word internet if each word begin with vowel? And second question is each word end with consonant. So 5. Let's see. A. The letter is here internet. Internet. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Total number of letters is here 8. We have to arrange so that each word begin with vowel. Okay, so we have to, so 1, 2, 3, 4, 5, 6, 7, 8. So first place will be occupied by only vowel means 1, 2, 3. We have 3 vowels, so either it should be I, E or E. Okay, so first place, for first place. Now it should start with, that means we have to put all the vowels together and it should be always, that means all the vowels, this first place will be occupied with any one of these. That means there are 3 choices for this first place, 3. Now word begin with vowel only, so any one of them may take place maybe in first position. So for remaining there will be how many places? So here this, so 3 choices for here, and then 7 they can be arranged 7, 6, 5, 4, 3, 2, 1. Okay, so this is the, so that means 3 into required wage will be simply here. So required wage will be 3 into, here we can write here 7 factorial, but we can see here we have 2n, so it should be divided by 2 factorial, 2n, this n and n, 2t, 2t, so it should be here 2 factorial. Again we can see here 2e also, E and E. So 2 factorial. Have to divide and cancel by, so it is here 3 into here 7 factorial means it is 7 times 720, because 6 factorial is now it is here simply 8. 2 into 2 into 2 into 2 into 2, 8. 8, it is 8 into 7, so 90. So let's multiply 21 into 90, it will be here 9 and 18, 9. So 1890 will be our answer for first part. Okay, now this is first one. We have solved first part. Now each word end with consonant. Let's solve how we are solving it. So this is first part. 1890 is our answer. So for second part, let's see how we are solving. Question number 5b. For 5b. Okay. So is each word end with consonant, means 1, 2, 3, 4, 5, 6, 7, 8. For last place we have to put only consonant, means either it should be here, so N, T, maybe R. So we are not allowed right here. I, E, E, not allowed. So N, T, and then it will be how much? So again, maybe T, maybe N. Okay, so maybe R. These are just 1, 2, 3, 4, 5. 5 choices remaining here. Again same as before, so it is 7 factorial. So required weights will be 7 factorial and into 5 by, see here, so as we have 2n, so 2 factorial, 2e, 2 factorial, and then 2t also, so it is 2 factorial. So if we divide as before, it will simply here 7 into 3, so it is here 7 means, and 720 by 8 into 5, so this into times 90, so it is how much? 35 into 90, so it is going to be 0, and 4 9 into 5 45, so 9 into say 3 27 27 27 and 4 31, so 3250 is your answer. Okay, so this is our final answer for question number 5. Let me solve another question for you. Now question number 6. So let's see, now up to question number 6. In how many ways can the letters of logic, the word is here logic, Logic. Okay, so in this video I'm solving questions regarding questions based on permutations. Okay, question number 6 for first part here, Logic is the word. So n equals how much? The total number of word is 1 2 3 4 5, n is 5. The first one, the vowels may occupy odd positions. The vowels may occupy odd position. 1 2 3 4 5. 1 2 3 4 5. So we have two vowels, 1 2. They have to be kept at odd position, means 1 3 5. So for first vowel there is 3 choice, for second 2 choice. Okay, so we have kept 2 places, suppose this and this 2. So 1 2 3 places are there, and that can be occupied by 3 consonants in 3 factorial ways. So it is here 6 into 6, it is 36. First one. For B, no two vowels are together. No two vowels are together means, so we'll solve here total weights first. Let's find total weights first. Total weights will be simply 5 factorial. So no two letters, all the letters are different, so it will be here 5 factorial means 120. And if R's are together, R's, so no vowels are together. Vowels if vowels are together, let us solve. If vowels are together, which will be how much? Let's put here vowels together means it will be here. So we have to put like this: O, I, and then this together, and then L, G, C. If they are together means these two are together. Two vowels are together, so it will be 1, 2, 3, 4. So 4 factorial into 2 factorial, because they can change their position. So it will be simply 4 factorial means 4 into 3 into 2 into 2. 4 3s are 12. 12 into 4, 48. So much will be there. So therefore required weights will be, that means in which no vowels are together, required weights will be total minus 48. So 120 minus 5 factorial. So 120 minus 48. This is this. So it is 10 minus 8 to 11, 72. Okay. This is the second part. For third one, let me solve for you question number 6C. In this case, what we are going to do, relative positions of vowels and consonants are not changed. It means here 1, 2, 3, 4, 5. So the position of consonants and vowels are same. There is no change in position. Means here, see here, consonants 1 and here 2, 3. So 3 consonants, 3 consonants. They can be arranged in 3 factorial ways, 3 ways, factorial ways, and 2 vowels. So it will be 2 factorial ways, and required ways will be simply 3 factorial into 2 factorial. That is here simply 3 into 2 into 1 into 2 into 1, and 4 3s are 12 will be our answer. Hope you understood this. Hope you are getting whatever I explained, and it's not difficult. It's all about your concept.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.